Hello students, how are you? Hope you are doing well. Now the question is, state any two properties of a nucleus. Why is the density of a nucleus more than that of an atom? And show that the density of the nuclear matter is the same for all nuclei. So the problem is based on the topic nuclei. The first part of the question is any two properties of nucleus. So there are many properties of nucleus, such that the first property is this, that nucleus is positively charged. We have to write this particular statement that nucleus is positively charged. It is because that it consists of two subatomic particles, which are the proton and neutrons. Neutron is a chargeless particle, whereas the proton is a charged particle. And the whole of mass of the atom is concentrated in the nucleus, as these two particles are the heavier counterpart of the whole atom. The rest of the part is in terms of the electrons, and electrons revolves around the nucleus, and these are lighter. The mass of the electron is very less as compared to the combined mass of the protons and neutrons. One more point, we can say that the nucleus is having the most dense part. So the most dense part of the atom is the nucleus. This is also one of the point which we can write. We have to write only two part, as I have telling you all the different parts, all the different properties. So one property is also that for the nucleus, the radius of the nucleus is given by this particular formula, where r is the radius of the nuclei, r naught is a constant, and a is the mass number. So r equals to r naught a to the power 1 by 3, a to the power 1 by 3. So this is the formula for the radius of the nucleus. So these are the certain properties of nucleus. Out of them you have to write only two. The second part is, B part is, why is the density of nucleus more than that of an atom? So the reason is, the main reason is, most of the mass of the atom is concentrated in the nucleus in a small space. The nucleus consists of proton as well as the neutron, and it is in the very small space. That's why it is the densest part of the nucleus. The density of the nucleus is mostly for the nucleus in an atom. Now in the C part, we have to show that the density of the nuclear matter is the same for all nuclei. It means that whether the nuclei of any element, the density remains same. So the formula for the density is mass upon volume. Now the mass is given by small m multiplied by A, where small m is the mass of the subatomic particle, such as the proton or the neutron, and A is the mass number. And volume is given by 4 upon 3 pi r cube, where r is the radius of the nuclei. Now from this particular relationship, that r equals to r naught a to the power a to the power 1 by 3, we put this expression here. So ma upon 4 upon 3 pi r naught a to the power 1 by 3 whole cube. Now after solving this, this becomes ma upon 4 upon 3 pi r naught cube a. Now this a cancels with this a, and the resulting ratio becomes m upon 4 upon 3 pi r naught cube. Now we can easily see that all of them are constant. So we can say that the density of any nuclei is same. So this is the solution of the C part of the problem. So hope you understand the solution. Thank you.